Welcome once again. I'm Charlie Greenberg, your host and moderator for Web Methods Wednesdays and Digital Business Demos. In the upcoming months, this series will be providing live business demos that focus on different digital transformation, platform strategies, and that also demonstrate different components and products within Software AG's digital business platform. Today, we're going to introduce you to Zementis, an exciting new solution for artificial intelligence, and how Zementis is used to enable machine learning in predictive analytics for fraud detection. That was a Freudian slip. In just a moment, we'll be hearing from Mark Rapkin, Director of Business Development, AI Strategy and Innovation, and Eddie Sung, Senior Global Pre-Sales Engineer, who will be executing today's demo. But first, I'd like to point out that today's presentation is brought to you by Software AG, a 48-year-old organization well known for customer-centric innovation. In fact, Software AG is ranked as a leader in many innovative and digital technology categories. We have more than 4,300 employees, $1 billion in annual revenue, and we can cite over 70% of the Global 1,000 as customers. And those customers include well over 2 million developers at leading organizations who have adopted Software AG products to innovate solutions cross-industry, cross-private and public sectors, and who rely on Software AG to complete their digital journeys by using the end-to-end capabilities of the digital business platform. Also, please keep in mind that following Mark and Eddie's presentation, we will provide a Q&A session. So as usual, please use the WebEx Q&A box at the bottom right-hand side of your screen for any questions and comments. And with that, it's my pleasure to introduce Mark Rapkin.
Thank you, Charlie, for that introduction. And let me just go over what the agenda today will be. Charlie's provided the overview of Software AG. I'm going to provide the overview of Software AG AI, and Eddie will go through and provide a demonstration that includes building an analytic model. In this case, we'll use R, how you would deploy that model using Zementis Predictive Analytics and utilizing that model within a complex IT environment. And then we'll get into a visual demo showing Zementis Predictive Analytics and Web Methods integrated, and as Charlie mentioned, conclude with questions and answers. And we're really looking forward to those, so we hope you'll participate in that. So Zementis was an independent company until December of 2016, just about 6 months ago. And Software AG acquired Zementis, and we became what's known as Software AG AI, the Center of Excellence for AI, Machine Learning, and Predictive Analytics within Software AG. And a good question to ask is, why did Software AG acquire Zementis? And it has to do with what Charlie mentioned, that Software AG is really focused on enabling large enterprises to succeed in their transformation into a digital business. And towards that end, we offer a digital business platform. Now, why is becoming a digital business critical to large enterprises today? Well, on this slide, I've just threw up a few, right, of the most well-known digital disruptors: Airbnb in hospitality, Uber in transportation, Amazon in retail. But the fact of the matter is that every industry and every company in every industry, if they're not facing a digital disruptor like these companies today, they will in the future. And the question is, what do all of these digital disruptors, older ones, younger ones, have in common? Well, they leverage the decrease in cost of high-performance computing power. They leverage the availability of broadband internet and the ubiquity of mobile computing, and combine that with AI, machine learning, and predictive analytics techniques with very good product design and marketing. And that's what's at the core of their success. And what Zementis enables is that same agility for large enterprises to be able to respond and create new products and services using AI, machine learning, and predictive analytics without needing to, open an office in Silicon Valley and compete for the most expensive and scarcest resources in the technical world today. And so I'll be talking a little bit about that and going through a demo as well. So where do we see AI, machine learning, predictive analytics being applied? Customer analytics, right? Whether it's retail, real-time customer behavior, or healthcare, for example. Operational analytics, which today is called IoT, all of the information coming off all of these devices, whether you're talking about predictive maintenance or autonomous or semi-autonomous vehicles, or all of the devices that we have that are producing data today and are connected. And Zementis, as an independent company, did incredibly well in risk management. So with financial services, should a transaction be approved or not? Looking at anti-money laundering and all these sorts of things. And what's interesting when you start to think about a lot of these use cases, customer analytics, IoT, risk management, almost every large company today has all three of those use cases. Now, they may be more focused on one than the other, but it's fascinating to see how this is all coming together as we get into the 24/7 real-time connected world. What we're going to be talking about is, the work that data scientists do, in that what they do is they design, develop, train, and test these analytic models. And then, across whatever platform they're using, they need to be able to deploy, integrate, and run them. In this case, I'm showing Software AG's digital business platform, and we leverage an open industry standard called the Predictive Model Markup Language. But we can also deploy, integrate, and run these kinds of analytics really in any IT environment. Just keep that in mind as we go through. And in fact, on this slide, I talk a little bit more to that. The left-hand column of this slide is the data science slide. So we've got a sample representative listing of the tools and languages that data scientists use to build these models. So SAS, SPSS, KNIME. In addition, often you'll find languages in use like R or Python. And with these, the data scientists will, excuse me, a little bit of problem with my throat today, will use, I've listed a sample representative listing of machine learning techniques that are commonly used but very complex, from deep learning to neural networks to random forest models and others. All of these can export to PMML, this open industry standard called the Predictive Model Markup Language. What Zementis Predictive Analytics does is we consume, execute, optimize, and scale PMML for really any technology environment. So whether it's a Software AG platform, a cloud platform, or you want to do something on Hadoop or on site, this is what we do. And the reason that this is important is often in a large enterprise, when the data scientists have built these models, it can take quite a long time, typically months, to get that model deployed. And that's for each and every model, because the deployment of each and every model outside of that data science development sandbox is an IT project. And it comes with all the stresses and frictions and distractions and costs and delays that IT projects come with. And in a world where almost every company is moving to dozens of these models that need to be updated, that need to be refreshed, where new models need to be produced to support new applications and services, and many companies are moving to hundreds, this is a business process that must be solved for companies to remain competitive. So with that, I'm going to turn it over to Eddie, who will take it from here.
Thanks, Mark. Let me share my screen. Okay, I take it everybody can see my screen now. Thanks, Mark, again, and hello, everybody. As this webinar is about embedding machine learning into application, we need to know what that means and how that is achieved. It is very clear that machine learning plays a very important part in business today, and more organizations are including that in their business processes. There are a number of steps involved. First, the model has to be developed, which is quite obvious to the data scientists, but not necessarily to the general population. Then it has to be deployed before it can be utilized by businesses. Utilization of machine learning technology, also called predictive model, is by way of applications being able to access the machine learning functionality to make predictions of a future outcome or event. In an enterprise that is going digital or has gone digital, it would help if we know how to fit our predictive models into digital framework. In this webinar, we will explore through an e-commerce fraud application example how machine learning can be applied in a digital business environment. There are various ways that machine learning can be introduced into Software AG digital business platform, and I'm going to call it DBP from here on. There is a layout, here's a layout of the various DBP components which you may already know about that may participate individually or in some combinations to deliver an AI-enabled business solutions. In this example, machine learning is applied to data streaming through Software AG complex event processing or CEP platform called Apama. I'm just going to go through some of the components here and kind of relate how it contributes or work with machine learning. Terracotta is typically used to accelerate data aggregation and looking to optimize prediction performance, thereby enabling the service level agreement compliance. Web Method Integration Server for data orchestration and transformation, but it also is used to create machine learning services, as will be demonstrated in this webinar. Mesh Zone NextGen is perfect for visualization, to be able to have visibility to the systems and applications performances. Also, sometimes it could be used for other kind of KPIs. I'll be demonstrating Zementis in all of this, and Zementis is, of course, the key component to operationalizing models. It is the engine that delivers machine learning to applications. Web Methods BPMS is for supporting the business workflows, alerts, and notifications keyed on the predictions at different decision points. We also have the Software AG Designer. It is used to build various component services to support the business application. There are other possibilities which are not covered here today. In today's demonstration, I will show how machine learning can be introduced using Web Method Integration Server and Mesh Zone. This demo was developed by our global pre-sales team and contributions from the pre-sales field organization. A stream of e-commerce payment transactions is being simulated in this demonstration and processed with the Web Methods Integration Server. The Web Methods IS has a flow package that provides REST connectivity to Zementis. We have created a custom Zementis flow package within IS. And the official so-called WM flow package for Zementis is in the product roadmap. The purpose of the Zementis flow package is to make IS the common point between applications and Zementis for machine learning capabilities. This will prevent the proliferation of point-to-point integrations between applications and Zementis, thereby reducing the cost and complexity of providing machine learning across the enterprise. One such function functionality is a REST call to Zementis server to return in this particular example, the fraudulent or non-fraudulent prediction on an e-commerce transaction using the fraud demo in our demo, the fraud demo that I'll be showing you. A scheduler will run this process of e-commerce transaction randomly picked from a data set of transaction records. The result is dynamically rendered in the Mesh Zone Next-Gen dashboard. Machine learning, predictive analytics, data mining, predictive models, deep learning, and a number of advanced analytics terms are loosely referred to as AI these days. Let's agree that while the above terms do mean different things in advanced analytics, rightly or wrongly, we will use AI as meaning anything advanced analytics in this webinar. AI wouldn't exist if there was no machine learning model. It has to be built and tested before anything else. The people who build models are typically the data scientists. It will be helpful to understand the journey or process that model takes for development to production of AI application. This is a little bit busy slide, but it does depict a closed-loop predictive analytics. To start with, the big picture of AI model lifecycle is depicted here. Like any software systems, it goes through development, then deployment and production. Of course, there are other sub-processes involved at various points. I'll talk about each phases quickly over the next few slides. Let's start with model development highlighted here in red. As a model is used to find patterns in data, the data has to be imported to an area where we can analyze and discover relationships and significance among them. Usually the data is not in the best form, so data pre-processing and transformation will usually have to be done. Depending on whether we are trying to solve a continuous or classification problem, certain machine learning technique is applied. After the model is built, it has to be evaluated against some test set to ensure accuracy. Once the model has reached an acceptable accuracy, it is exported to PMML format in preparation for deployment into production. Now, model can be built with different data mining tools, obviously, and languages as well. Some commonly used ones are R, Python, KNIME, SAS, IBM SPSS, etc. I'm going to demonstrate the creation of model in this particular webinar using R. I have up on the screen an R Studio IDE, which is a very common data mining tools to build models with, and it supports the R language. What I have in front is a model, which is the e-commerce fraud model, and it is based on neural network. And what I wouldn't go through everything here, but I just want to give you an idea of the process that I just conveyed in the diagram here in the source code itself. This is a model script, and all these are our statements, and we're going to be running all of this. It's using different libraries that are necessary for this model script to run, and you see that it's running here. I ingested some data sets in here, and over here, this kind of an example of data discovery or data transformation. Here, I'm trying to find out if there is any missing values, which is an important thing here. So you can see that at the bottom, these are counts of the various attributes in the data, and the number of a missing value, all of them says 0, so that's great news. That means I don't have any missing values. Now, there are more than just looking for missing values that is involved in the pre-processing part and the transformation. but that's just one. That's just an example. At that, because we're using what we call the supervised learning, we need to break up the data into two parts: the training set and the test set, and it is done with using a certain common process of typically taking 30% of the original data set for tests and the remaining 70% for training. And this part here is another pre-processing step. We're converting any qualitative variables to dummy quantitative value, because the neural network does not take, has to be quantitative values. So that sets it up. And now this here is where we create the model. This is a call to the neural network function, and this is the parameter that you passed in with this formula here. This is the formula that we use to tell the neural network machine learning technique, which is in the form of a function, to use these variables in order to create the prediction. And this is the training data that we're passing in, and some parameters for this particular neural network machine learning technique. By executing this, it is not only creating the model, the model, but it also trains it, because we pass it the training data here. So a lot is happening inside of this function. It is a very complex thing that we don't really need to know in general, unless you are maintaining this functionality. But otherwise, you just use it as I do here, and it's get assigned to this variable and then model. Now, then I do the same for the test. I'm doing it. Did some pre-processing on the test data, and then I do a prediction using the test data. And technically, you should be comparing the results against and doing some sort of matrix to find out how accurate it is, but I'm not doing that right now. What's important I want to get to is now that you have a model, and assuming that it is it's acceptable, you want to be able to export it to PMML. Now on the right-hand side, this is the workspace that I'm in the file system that I'm working on. Now I'm going to create the PMML by executing this PMML command to convert it to the model to PMML format, and then I'm going to save it out to XML. And you'll see that this file just showed up. So that PMML is now ready for production. All right. So we'll switch back to all right. So now that you have seen an example of how a model is built, we need to now put it into production so that the business can use it. In this step, prior to loading into production, I need to share with you some of the things that happened while the model is in production. And this is the model monitoring and maintenance section where the data, I'm sorry, so this is the deployment, getting ahead of myself here. So this step is where we operationalize the model. Because of Zementis, we can simply take the PMML file that we have just built and upload it onto Zementis server. This usually involves data science team officially handing over the PMML to IT. This process takes only minutes. Note that traditional methods rely on typically recoding the model into standard programming language like C, C++, Java, etc. Such undertaking is no different from any software deployment, involving a number of resources from both the IT and data science teams. For this reason, this is why Zementis offers a huge advantage and value in the operationalization of models. Let's look at how a model can be deployed One way is to use the Zementis server web console. The Zementis server is a web application, so I get access to the console through this URL. I'm going to log in, and when I get into the console, I can see all the models that are already in the system. And let's say I want to upload the PMML that I just created. This is the PMML that I just created, the e-commerce x.pmml, and that was created just now. And I just select that and upload it. Simple as that. And with that, you'll see that now we have an e-commerce fraud and an X. This is the one that I just loaded. That is pretty much it. Of course, you can score the data or do prediction on batch data here, and a number of other functionalities. But I would like to proceed on to the next step. And let me just do that. Switch back to here. So that was the deployment part. And now, as I mentioned, that when a model is in production, there's also another function task that needs to be done on a continuous basis, and that is to monitor the model, making sure that it is still accurate and all that. So it is a common practice to be doing that. And what that does is keeping a regular track of the models that has been deployed, and it involves measuring the prediction performance of the model in production and/or against other models for the same use case. If the model's predictive performance is declining or has become inferior compared to other candidate models, then the data science team is consulted, where either the existing model is retrained with more recent data, or the data is switched out with a more suitable one for the time. The best model is usually called the champion model. When the best performing model is deployed and is in production, business users will use it for various applications through the organizations. In this demo, the WebMethodIS flow service will be used to invoke the e-commerce model that we just deployed to help us predict if the e-commerce transaction we are receiving are suspected of being fraudulent. Typically, the application gets the prediction from Zementis, usually called SCORE, and pass it on to some business process, which will enforce certain business workflow and alerts and notifications wherever necessary. It is common to have some sort of visualization as well. One way to implementing this is through the use of web method BPMS for workflow and alert and notifications. The web method mesh zone and next-gen is ideal for the visualization. In this demo, we will leave the use of web method BPMS for another session, but we will demonstrate the use of mesh zone next-gen to visualize our e-commerce transaction. It is now time to dive into our short demo, starting with our e-commerce flow service in web method integration server. I'll first run through the demo and then talk a little bit about the implementation details. And let me start. Now, in this demo, I have a service inside web method integration server, and I have a scheduler that kicks it off every 5 seconds here. And that is to not only simulate the stream of e-commerce transaction, but also to score it and then have it available for visualization. And here is the Matchstone dashboard, keeping a track of the e-commerce transactions that's coming in. On the left side, we have a transaction monitor that shows the different transactions coming in and the channel that is coming through, the state is coming through, customer ID information, and certain attributes about it. And on the right-hand side that is color-coded is the predictive status of whether the transaction is fraudulent or not. So this is real time, and over here we have a track of some stats about the fraudulent versus non-fraudulent over transaction in the various states, and over here transactions from different state and from different channel. So this is coming through. It's reading in this particular demo, it's reading the data from a CSV file. And it doesn't have to. I'm continuously appending it to CSV file, but the data could also be coming from universal messaging through JMS. That could be a different implementation. So let's look at how this is implemented. I'm in the Software AG Designer, and I'm in the service development perspective. I was earlier mentioning about the Zementis integration package, which is this. This is a custom application, a custom flow package rather, and it has implemented the various REST calls to Zementis to do different things like delete model, get models, put models, and this get apply is the one that we use to send data and get the score back from a model that we specify in this functionality. You don't build application here or any flow package here, but you do it from another flow package, in this case, in our example here. We have a run test. And this is the flow. And this view section here, that's just to simulate the e-commerce transaction coming in. And here is where we call the make a call. This is where it calls the Zementis flow package, which will then call the Zementis server itself for scoring. And so this is the score fraud. Like this is where we are making a call to Zementis. So over here, there are certain mappings that happens. And this is the part where we call this Zementis package right at the bottom here. So you don't have to re-implement this particular call to Zementis every time. So this is the advantage of having this Zementis flow package. As I mentioned, this particular kind of Zementis package will eventually be delivered as part of this WM package, which are the read-only, if you will, libraries for commonly used functionality within web methods integration. So, so that's pretty much how it is implemented. As I mentioned, I'm writing it to CSV file, but You could, in actual practice, you would probably use writing out into some sort of a pipe or through GMS or other queues. So again, so that's the implementation part. So that's a quick demo of that. And with that, to recap, we're embedding AI in a digital environment, and it's simplified using software AG DBP. Model is the foundation of AI. There's a well-defined process and actors in building, operationalizing, and using AI across enterprise. The demo is more suited for at the moment or in on-demand use case, as I would call it. It's not, if you were to want to use this for very fast real-time streaming, very high volume streaming, then that's where you would use the software AG complex event processing platform, which is APAMA. That's a topic for future webinar. So that's pretty much all I have for today's webinar. I'm going to pass it back to Charlie.
Thank you, Eddie, and thank you, Mark. And as we go to the final screen of today's presentation, let's get to some questions. And I have a few that involve modeling, so I'm aggregating those, I think, to maybe we'll get a little storyline going here. Number one, how does a model know whether or not the data it is executing against is valid data?
Sure. So this is Mark. I'll go ahead and answer that. So PMML has the capability within it to do a lot of pre- and post-processing of data or data handling and transformations. So what that means is when it's looking at data, whether it's looking at batch data or it's looking at real-time data, it can look at data and say, oh, is this good data or bad data? It can infer a missing value if it needs to. It can handle an outlier. It can smooth data out. It can do all those different things that it needs to do, which is very important prior to scoring the data. Now, PMML has quite a few capabilities in that area, but it's not a substitute for a database. So what databases are really good at are aggregations and joins and things like that. So you want to do that kind of manipulation in the database, but again, particularly when you're talking about streaming data, whether it's coming through APAMA or streaming platform or Spark or Storm or something else, all of those platforms which we support, that is how we go about looking at the data prior to scoring it.
Thank you, Mark, for that first response. And just as a reminder, everybody being attendees, please use the WebEx Q&A box at the bottom right-hand side of your screen for any questions or comments. Here's another model question. If using a model in real time, 24/7, 365 days a year in a production environment, how do I switch it out to a new model?
Sure. So let's say we're in June now, and you've got a model that's good for this month. So you've got your June 2017 model up. That's going to be a .pmml file. So last day of June, perhaps, you're going to put up your July 2017 .pmml model, and it's going to be in place and scoring data. And then you're going to pull the June model down, and the July model will be there. And so you can do that, you know, at the timing that you want to do, and that way you have no gap in scoring. For a brief period of time, a moment or two, you will be receiving scores from both models, but you'll know how to handle that.
And let's do one more modeling question. So maybe this is more about best practices, but who decides when a model needs to be retrained? Data scientists, business, both?
That's going to be a business process that should be a conversation between the data science and the business team, and as well as IT. So most likely you're going to be doing, well, there's several influencers to that event. So it may be that you're monitoring the performance of the model, and over time you're seeing that the model's not performing as well as it used to based on the metrics that you're measuring it against. So in that case, at that point, you're going to have to look at revising, retraining the model if you want to get the model performance back up to where it needs to be. Now, the other thing that can happen, and this happens more frequently today than perhaps it used to in the past, is that there is a new data source that you want to add to that model, or there is a change in the application or service that model is supporting. So in that case, of course, then you're going to want to revise the model so that it is contemporary and up to date. And I would point out that that is one of the motivators for companies that use Zementis solutions, because they're finding in today's environment things change far more rapidly, and the required responses to for consumer or industrial needs are just more real time and on shorter time frames. And so the ability to, in a very agile and rapid way, develop and deploy becomes incredibly important in supporting the business going forward.
Next, I have, I guess, a multi-part question, so I'll try to do it slowly. Take notes, please. Can you talk about the value of ML versus traditional approach? Why neuron network? How this can be applied, for example, to payment transactions?
Sure. So, ML, just to be clear, stands for machine learning. And I think in reference to traditional, what's the difference between predictive analytics, machine learning, and neural networks are typically referred to as AI or artificial intelligence. So what I think I'll do to answer this question is compare and contrast predictive analytics, machine learning, and artificial intelligence in a way that we can all understand. So predictive analytics we all experience today when we go on to Amazon or we go on to Netflix or any other site where, based on our past history, they're running a recommendation engine, right? So they're saying, oh, if A, B, and C have happened in the past, there's a high confidence or high probability that this consumer that's purchased A, B, and C will purchase D. Let me show them relevant offers, right? That's a great example of predictive analytics that we're all familiar with. Machine learning, I like to use the example of credit card fraud. Let's say that we've built a machine learning model to detect credit card fraud, and we're running it nationwide in the United States. And we see, the model sees a spike in fraud, in the percentage of transactions coming through. All of a sudden, there's much higher fraud in one city. Let's say it's Cleveland, Ohio, for this example. The model will have within it the capabilities to tighten up the constraints on approving transactions coming through Cleveland, Ohio, until the proportion of fraudulent transactions that are coming through goes back down to a normal level. And again, it can do this multiple times or across different cities and geographies. And so that is an example of a machine learning model where it is adjusting itself based on what its experience is and the parameters that have been provided to it. artificial intelligence typically refers to today natural language processing and or the processing of images. And so, for example, the most obvious and most talked about example, if you're in the tech industry today, is driverless cars. And the example I love about this is one thing driverless cars are often programmed to do is to confirm the speed limit at which they're supposed to drive by registering when they pass a speed limit sign. And so that makes a lot of sense, right? Well, it turns out that one of these driverless cars at one point got behind a truck, and the truck had one of those bumper stickers on it that said, I don't go above whatever speed it was, 60 miles an hour. And it registered that as the speed limit sign, which would have been okay, except this happened to occur on the Autobahn in Germany. And so the car was going much slower than was safe. And these are the kinds of problems that are very hard for AI. You know, that's the edge of where AI is. But that it uses neural networks typically to do these kinds of complex learning where you're weighting different pieces of data and information in a very complex way. Hopefully that explains that relatively well.
This is Eddie. I'd like to put a different perspective to that, if I may.
Sure, please.
I think the question, if the question is asking whether we're using, you know, or what's the difference between machine learning versus traditional approach, i.e., maybe descriptive analytics, then the answer is that the machine learning gives you the predictive nature of being able to predict what may happen in the near future versus what's already happened. So if that's the question relating to that, then that's my answer. In terms of neural networks, it doesn't have to be neural networks, but neural networks is a very sophisticated modeling technique. In the example I used in neural networks, I could use other techniques. In practice, the data science team would potentially write different types of models for that particular kind of problems, i.e. classification or a continuous type problem. Then it will pick the ones that has the best performance, as I mentioned in the model maintenance and monitoring, where they pick a champion. So that could be it. So the champion could maybe a neural networks, maybe not. Maybe it could be a random forest. Maybe a simple regression could be good enough. So it doesn't have to be. And in terms of applying it to payment transactions, the demo is an example where we apply the machine learning technique to identify potential fraud. Hopefully that answers your question.
And I would add also to that from a Zementis solution perspective, whether you want to use the simplest kind of model imaginable, which is typically linear regression, some of these medium-level complexity techniques, or the most cutting-edge techniques, whether that's neural network or deep learning, we are able to take all of those techniques into the predictive model markup language, PMML, and again, apply the Zementis server to them such that they can be consumed, executed, optimized, and scaled for whatever IT backend you need them to be working in.
Thank you for that in-depth response to what turned out to be an excellent question. And Mark, I really did like the predictive driving use case. But since you just mentioned PMML, let me ask you this. What if I want to use, this is from a questioner, an analytic outside of the PMML standard?
Sure. What we enable is for, so the first thing is PMML has such broad level of support for different model types. Generally, the problem can be solved with a PMML supported model type. But maybe you want to do something different. And you want to use Zementis. If you code that in Java, we can then call it from within the system as a custom function, and everything will work perfectly.
There's a question actually coming back to our longer question, a follow-up, which began, can you talk about the value of machine learning? And that is, can you talk about the comparison of performance improvement?
Comparison of performance improvement. I'm not sure I understand the question. Eddie, can you infer what the question is from that?
If I understand the question correctly, it's asking what do we actually compare when we talk about performance improvement. I think if that's the question, then when we do performance measurement and monitoring comparisons, we're comparing the accuracy of how well it's able to predict versus the label data. So we have data set that has the outcomes that we already know, and if we predict, make a prediction, and how many of those predictions did we get right against the label? Label meaning, you know, the actual result. Let's say we said that this thing is red. That for this data, that red is the label for that data. And then when we predict, we want to make sure that we are as close to, we are equal to, we're getting that label correct as many times as possible. So the higher percentage it is that we get right, the better. So that's what that is.
Thank you. And if, just so you know, since we're getting toward the top of the hour, if you don't hear your question answered, or if one occurs to you after we've stopped, please note at the bottom of this slide is Mark and Eddie's email addresses, and they look forward to reaching out to you or having you propose a question to them. So please feel free to use that. And since we're eyeing the slide at this point, I just want to point out that in addition to these platform demos, which are coming up into August and beyond, we can only list so many, we need to tell you about next June 21st, that is in this month, we have a hybrid integration demo and presentation, but more specifically, it's going to focus on cloud integration for non-technical users. You can well imagine that has something to do with connecting through configuration as opposed to mostly coding. So please keep that in mind. And here's another question. Will this system work if I am looking at extremely high volumes of transactions and SLAs in the milliseconds?
Yes. So we can typically meet transactions, SLAs, in the low milliseconds. And there are two versions of our product. One is a server-based product, and we've had customers put together server clusters that have that are transacting more than 1 million events per second, so very high volume. We also sometimes use an in-database embedded solution, and we benchmarked this on Teradata Aster several years ago. And on those benchmarks, we were processing 8 million to 16 million records per second. So pretty much any volume, any speed that you need to reach, we can probably scale and meet. Some of that, if you're doing extremely high volume and with a extremely fast need, we would look to perhaps run on premium hardware. We do run much, much faster on higher performing hardware, but we can run on commodity Linux servers as well.
Let's have one more question before we conclude, and I'm going to modify it. But can you compare Zementis to other competitors in this space?
That's a broad question. I'm not going to say that we are the only solution in the space, so there are other frameworks and methodologies that you can use to accomplish similar results. We are the only solution that is focused on commercially supporting PMML as the method for doing this. PMML is an open industry standard. It's managed by the DMG group. It's 10+ years old and is supported by the likes of Software AG and SAP and SAS and IBM and on and on. And so we think that this idea of being not locked into a particular vendor for both data model development as well as deployment is a very good thing. So if you go and talk to a chief data officer, they will always say, hey, can you make me less dependent on SAS if they're using SAS, because that has become such a big dependency and it's a walled garden and it's very hard to loosen that control, and they don't have a lot of pricing negotiating power. So we think decoupling the development of the models from the deployment of the models is the right solution from a technical perspective as well as from a business perspective, and the fact that we use a well-defined and mature open industry standard, we believe, is a significant competitive advantage.
I want to thank once more Mark Rapkin and Eddie Sung for providing us with this excellent and rather fascinating introduction to Zementis at Software AG. Please note that, as I mentioned before, we are doing this weekly demos that are part of the digital business platform of Software AG, and we welcome you every week, including once again next Wednesday, June 21st, for cloud integration for non-technical users. Until then, have a great rest of the day. Take care.